Welcome to today's class on partial derivatives. Today we discuss functions of several variables. So first we define functions of several variables. So this is the definition. Suppose D is a set of n tuples of real numbers x1, x2, etc. xn. A real valued function f on D is a rule that assigns a unique real number w that is equal to f of x1, x2, etc. xn to each element in D. The set D is the function's domain. The set of W values taken on by f is the function's range. The symbol W is the dependent variable of f, and f is said to be a function of n independent variables x1, x2, etc. xn. We also call xj's as the function's input variables, and we call w as the function's output variable. So we can give some examples of function of several variables. Example 1, f defined from R3 to R, the space R3 to R. You know the space R3 is like this. This is R3, x-axis, y-axis, z-axis, 0. So from here to set of reals defined by f of x, y, z equal to square root of x square plus y square plus z square. So this is a function of three variables defined from R3 to R. So R3 is the space, R is set of reals. So this is an example of a function of three variables. Now we can give another example. So consider a function from R2 to R defined by f of xy is equal to sin xy. So here this is a function from the plane R2. So this is x-axis, y-axis, and so this is R2 to set of reals R. So this is an example of a function of two variables. Now we discuss some problems which includes finding of domain and ranges of functions of 2 and 3 variables. So we do the first set of problems. So question is this: find domain and range of the following functions of several variables. So first set is functions of two variables. So these are the problems. So this is first problem. Problem number 1, 2, 3. You consider problem number 1. Z is equal to square root of y minus x square. That is, f of xy is square root of y minus x square. You know that this function is defined for all x and y such that y is greater than or equal to x square, because the square root of negative numbers is not defined on set of reals. So we have f of xy belongs to R if and only if y minus x square is greater than or equal to 0. That is, y is greater than or equal to x square. Therefore, the domain is set of all x, y in R2 such that y greater than or equal to x square. Now we find the range of f. We find the range of f, for which you let this to be D, the domain to be D. Then for all x, y in D, we have square root of y minus x square is greater than or equal to 0. Therefore, range of f of xy is equal to square root of y minus x square is the set 0 infinity closed at 0. Problem number 2, we have f of xy is 1 by xy. We have 1 by xy is defined for all x and y such that x into y is not equal to 0. Therefore, domain of f is set of all x, y in R2 such that x into y is not equal to 0. Let it be D. Now we find the range of f. So we have f of xy is 1 by x into y. Therefore, for all x, y in the domain of f in this set, we have f of xy is not equal to 0. Therefore, the range of f is the set minus infinity 0 or union 0 infinity. Open interval minus infinity 0 union 0 infinity. So this is the range of f. So you know that when xy belongs to D, 1 by xy belongs to minus infinity 0 or 0 infinity. We do problem number 3. We have f of xy equal to sin xy is defined for all xy in R2. Therefore, the domain of f is R2, the entire plane. And we have whatever x and y be, sin xy varies between minus 1 and 1. For every x, y in R2, we have sin xy varies between minus 1 and 1. Minus 1 less than or equal to sin xy less than or equal to 1. Therefore, range of f is closed interval minus 1, 1. We do some problems from functions of 3 variables. Now we do these problems. Problem number 1, problem number 2, problem number 3. So find the domain and range. So we have the first problem is f of x, y, z is square root of x square plus y square plus z square. We know that this is defined for all x, y and z. Therefore, domain is R3, the three-dimensional space. And we have square root of x square plus y square plus z square is greater than or equal to 0 for all x, y, z belongs to R. Therefore, range of f is interval 0 infinity closed at 0. So it includes 0. We consider the second problem, problem number 2. Here f of x, y, z is 1 by x square plus y square plus z square. We know that f of x, y, z is defined for all x, y, z except 0, 0, 0. So we have 1 by x square plus y square plus z square is defined for all x, y, z belongs to R3 except 0, 0, 0. Therefore, domain is of f is set of all x, y, z in R3 such that x, y, z not equal to 0, 0, 0. So you have domain of f is set of all x, y, z in R3 such that x, y, z not equal to 0, 0, 0. So this is actually set of all points in R3 except origin. Now for x, y, z in the domain of f, we have 1 by x square plus y square plus z square is greater than 0. Therefore, the range of f is open interval 0 infinity. Now we do problem number 3. We have ln z is defined for z greater than 0. Therefore, domain of the function f of x, y, z equal to x, y, ln z is set of all x, y, z belongs to R3 such that z is greater than 0. So this is actually the half space. So we have this is x-axis, y-axis and z-axis, and z greater than 0 means the upper half of R3 space. So this is the half space. So that is the domain of this function. We have x, y into ln z belongs to R for all x, y, z in the domain of f of x, y, z equal to x, y, ln z. Therefore, range of f is R, that is equal to minus infinity, infinity. Open interval minus infinity, infinity. Remember, minus infinity, infinity are extended real numbers. Now, we have to do some homeworks. Question: find the domain and range of the following functions. So, do these problems as homework. And that's all for today. Have a nice day.